Hey YouTube, this is Kyle from Mr. K's Math and Science channel. Today's video is on isotopes and ions. The primary focus will be on isotopes. Let's get going. Isotopes are atoms with the same number of protons but different numbers of neutrons. The different numbers of neutrons causes different masses for the same element. In this table, we have three isotopes of hydrogen. You have hydrogen 1, which is a mass of 1. You have deuterium, which has a mass number of 2. And you have tritium, which is a mass number of 3. Hydrogen 1 is made up of 1 proton and 1 electron. Thus, its mass comes from that 1 proton. Deuterium is made of 1 proton and 1 neutron. Thus, its mass is 2 AMU. Then tritium is made of 1 proton and 2 neutrons, giving it a mass of 3 AMU. Also listed in the table is the relative abundance. So hydrogen 1 is 99.985% abundant. The other two isotopes of hydrogen have very little relative abundance. So let's try a quick exercise. We want to identify which pair below out of A, B, and C are isotopes, and we want to identify which pair has the same number of neutrons. As a reminder, the atomic symbol is symbolized with X, X being the element symbol. In this case, we're using a generic X. The upper left-hand corner of the atomic symbol is A, the mass number. That number is generated from the number of protons plus the number of neutrons. In the bottom left-hand corner, we have Z, which is the atomic number, and it's also the number of protons. So the first question, or the first objective here, is to find which of the pairs are isotopes. So in order to be an isotope, you have to have the same atomic number, or the same number of protons. So we need the Z to be the same. So that rules out pair A, because we have 8 protons and 7 protons. So then if we go down to pair B, we can find the first one that has equal number of protons. If you quickly look at C, you'll realize that those numbers are different as well. So B would have to be our pair of isotopes. Because the atomic number, or Z, is 6 in both of those atomic symbols, we have the same element. So the only thing that's different is the number of neutrons, which give different mass numbers A, 12 and 14 respectively in pair B. So the next exercise is to determine which of the pairs has the same number of neutrons. So off to the bottom right hand corner, I've given you a quick algebraic expression. The mass number A is equal to the number of protons plus the number of neutrons. So we can solve for number of neutrons. The number of neutrons is equal to the mass number minus the atomic number. So if we take A minus Z for the pair A, we get 15 minus 8, which is 7, and 15 minus 7, which is 8. So those are two different numbers, and therefore they are not the same number of neutrons. In pair B, we have mass numbers 12 and 14, and the atomic numbers are both 6. So 12 minus 6 is of course 6, and 14 minus 6 is 8. So those are not the same number of neutrons. So by a process of elimination, the answer must be C, but let's take a look. So 15 minus 7 is 8, and 16 minus 8 is 8. So therefore, pair C has the same number of neutrons, which is 8. So now we're going to try another exercise. We're going to fill out this table. Might be useful to have a periodic table nearby. So in this table we have the name of the element symbol, Z, which is the atomic number, A, that's the mass number, remember that's the protons plus the neutrons. We have P with a superscript plus, that's the number of protons. We have E, superscript negative sign, that's the number of electrons. We have N, superscript 0, number of neutrons. And then we have the atomic symbol. So to complete this table, let's start with aluminum. So for the aluminum example, we were given Z, which is the atomic number of 13, and we were given N as 14, that's the number of neutrons. Because we're given Z, the atomic number, we can quickly go to the periodic table and find that the atomic number 13 corresponds to the element aluminum. So we can fill out the name and the element symbol. We can start the atomic symbol. Also, the atomic number is the number of protons, so we can fill in P plus for 13. In neutral atoms, the number of protons is equal to the number of electrons, which is 13. So then the only thing left is to determine the mass number, A. The mass number A is the sum of the protons plus the neutrons. So 13 plus 14, which gives us 27. Looking at the next example, silver, we were given the element symbol Ag and the mass number of 108. So from the element symbol, we could find that element on the periodic table, identify that it is silver. We can get the atomic number, Z, which is 47. Then we can populate the proton and electron columns, 47. Because we have the mass number of 108, we can determine the number of neutrons. The number of neutrons is the mass number minus the number of protons. And I believe I did my math right. 108 minus 47 is 61. With that, we can complete the atomic symbol. We have the element symbol already. We have the mass number. So the next example, potassium, we were given just the atomic symbol. But the atomic symbol tells us a lot. Of course we have the element symbol, and we have the mass number. So from the symbol, if we did not know what element that was, we could find that from the periodic table, and you'd find it to be potassium. You can get the atomic number Z, which is 19, then populate the protons and electrons with 19. Because we have a mass number of 39 that was given to us from the atomic symbol, we can populate the column for A, mass number. And now, with the mass number, we can subtract the number of protons to find the number of neutrons. So 39 minus 19 is 20. Then the last example, nitrogen. We were given atomic number 7 and mass number 14. Because we have atomic number 7, we can populate protons and electrons as 7. Mass number minus the atomic number gives us the number of neutrons, which is also 7. The atomic number of 7 tells us that the element is nitrogen. And then we can complete the atomic symbol. Alright, let's try one more exercise. In this exercise, we're trying to find out the number of protons, neutrons, and electrons for these examples. But I've thrown a little twist in here. Previously, we discussed how when protons are equal to the number of electrons, then you have a neutral atom. but in this case you'll see, for examples 3 and 4, these atoms are charged, oxygen being a -2 charge, and tin being a +4 charge. So we're going to take a look at how we address those. So for our first example, sodium 23, when you see an example written like that, sodium with a hyphen and then a number, that number is the mass number. It's called hyphen notation for isotopes. So we have sodium 23. Because we have the element name, we can go to the periodic table and find the atomic number, which is also equal to the number of protons. So in these examples, notice I've cheated a little bit and I've used P, N, and E as my proton, neutron, electron symbol. Keep in mind that's not exactly accurate. So for sodium, we have 11 protons. Because it's neutral, we also have 11 electrons. In order to find the number of neutrons, you take the mass number 23 and subtract the number of protons, which should give you 12 neutrons. The second example, we have carbon 14. I got a little bit lazy here and did not include Z in the atomic symbol, but keep in mind that all these examples could also have the atomic number, or Z, in the lower left hand corner of that atomic symbol. So again, carbon, you can go to the periodic table and find that its atomic number is 6, therefore it has 6 protons. Because it's neutral, there is no charge, we have 6 electrons. Since the mass number is 14, you can take the mass number, subtract the number of protons, and get the number of neutrons. So 14 minus 6 gives you 8 neutrons. So numbers 3 and 4 might get a little bit complicated. Now we have ions. Ions are charged atoms. So we have oxygen 15 with a 2- charge. So again, oxygen, you can go to the periodic table, find the number of protons. It's the atomic number 8, so there's 8 protons. With that information, you can take the mass number of 15, subtract the number of protons, and determine the number of neutrons. So 15 minus 8 is then 7. But because we have this 2- charge, we need to figure out how to work that. 2- means there's extra negative charge. So oxygen has this 2- charge, which means it has more negative stuff. More negative stuff than the positive stuff. So more electrons and protons. So I provided a quick algebraic expression off to the right hand side of this slide. Protons minus electrons equal to charge. So if we plug in the information that we know, we have 8 protons. We're trying to solve for electrons, and we have a -2 charge. If you rearrange that equation, move the 2 over to the left, move the electrons to the right, you get 8 plus 2 on the left and electrons on the right. 8 plus 2 is 10, and therefore we have 10 electrons. If you think about it, 8 protons and 10 electrons, you have 8 positive charges, 10 negative charges. So for every positive charge, a negative charge can cancel it out. But once you run out of 8 electrons to cancel out those protons, then you have 2 extra electrons, and that's where our -2 charge comes from. So the same can be said for tin, Sn. So we have tin 119 with a 4+ charge. From the periodic table, you can find out that the atomic number is 50, and therefore you have 50 protons. You can determine number of neutrons from the mass number, subtract the protons from the mass number, so 119 minus 50, and I believe that's 69. But because now we have a 4+ charge, we have more protons, or more positive stuff, than electrons, so more positive than negative. If you use the equation again in the box on the right, plug in 50 for protons. We're trying to still solve for electrons, but you have a 4+ charge. So 50 minus what gives you your charge? Yeah, so the answer is 46. 50 minus 46 gives you a 4+ charge. If you have any questions or comments about this video, or would like to suggest content for future videos, send me an email at stein51687@yahoo.com. Thanks for watching. Be sure to subscribe.